Hello and welcome to EduMath. My name is Makumba Gerard, and in this video we are going to look at drawing the frequency distribution table and finding the measures of central tendency for data with decimal places. And if you are new here at EduMath, consider subscribing and hitting that notification bell such that you are notified whenever we make any new uploads. For now, we can start with a guiding example. The table below shows the height of 20 plants selected at random in the garden measured in centimeters. Here is the table, and then they need us to form the frequency distribution table using a class size of 0.5. And after that, we need to use the frequency distribution table that we have drawn to find the median height, the mean height, and the model height. Now, here we observe that we've been given raw data, and therefore should be able to organize this data here into classes, but those classes will have an equal class size of 0.5. So we're going to start drawing the table here. So within the table we shall have headings of height, we shall have the tallies because this is raw data, and then we shall go ahead to get the frequency, and that will be the frequency distribution table. The rest of the other columns will be added depending on the need in the question. First, they have given us that the class width is 0.5. Now what we do first here is to scan through our data and see the smallest value. So when you look through, the smallest value is 5.1. So that means we can rescale and have our first class starting from 5.02. Now, since the class width is 5, we should come up with our classes in such a way that when we are to compute the class width, it should be 0.5. So this should be going up to 5.4, such that when it comes to getting the class boundaries here, since this data is to one decimal place, the tolerance error is going to be half times 10 power negative 1. The tolerance error is 0.05. So when you subtract 0.05 there, we shall be getting 4.95 to 5.45. Now when you subtract here, surely the class width is 0.5, this which is given to us. We get 5.45 minus 4.95. We get the class width which is given to us here, which is 0.5. The next classes are going to be obtained in a simple way, just getting the class width, and you keep on adding until we make sure that the biggest value here is covered. So we scan through again, and then we identify the largest value. So the largest value here is 7.3. Alright, so we start plus 0.5, which is the class width. We get here 5.52 plus 0.5, we get 5.9. This is 6.0 to 6.4, and this will be 6.5 to 6.9. And 0.5, this will be 7.0 to 7.4. So our biggest value is 7.3. It is already covered. So the next thing is we are going to get the tallies. So we are going to start tallying. 6.1 belongs to this class. 5.6 here. 5.3 belongs here. 6.7 belongs to this class. 5.4 belongs to this class. 7.1 belongs to that class. 6.6 belongs here. 6.4 belongs to this class here. 6.3 belongs in here. 6.2 belongs in here. 6.0 is making a bundle here. 5.1 belongs to that class. 5.2 belongs here. 6.9 is a value that belongs here. 6.5 belongs here. 5.7 belongs in this class. 6.2 belongs in this class here. 5.9 is a value that belongs there. 7.3 belongs here. 6.4 is a value that belongs here. Next, we go ahead and get the frequency. This is 4, this here is 3, this is 7, this here is 4, and here we have 2. So when we happen to sum up all of those frequencies, we should be able to get 20. Just to confirm, this is 7 plus 7 we get 14 plus 4 we get 18 plus 2 giving us the 20. So next let's complete the class boundary. We subtract 0.05 from the lower class limits and add 0.05 on the upper class limits as we have always done. I'm also going to link a video about class boundaries in the cards up here. So this will be 5.45 to 5.95, 5.95 to 6.45, 6.45 to 6.95, 6.95 to 7.45. So those are our class boundaries. So you observe that when you subtract the upper class boundary minus the lower class boundary of any class here, we shall be getting the class size, which is the class width. Next, they need us to find the mean. So to find the mean, we need to have fx. So in our table, we are going to include columns of x and fx. So we shall have here x, this will be fx, and we shall have the cumulative frequency. X is the average of the two extreme points of the class, so that will be 5.0 plus 5.4 divided by 2, which gives us here 5.2. We can now keep adding the class width, which is 0.5, because our class width is uniform. So this will be 5.7, this will be 6.2, 6.7, 7.2. Next, we need to get fx. 4 times 5.2 here, we are getting 20.8. 3 times 5.7, we get 17.1. Then we have 7 times 6.2, then we get 43.4. The next one is 4 times 6.7. Get here 26.8. 2 times 7.2. Get 14.4 here. So next we need to get summation fx. So we are going to add here, we have 14.4 plus 26.8, we get 41.2 plus, we are also going to add this and that, we have 17.1 plus 43.4. So this here is plus 60.5 plus 20.8. So right now we have three values to add. We have 41.2 plus 60.5 plus 20.8. There we go. We are getting 122.5. So this is what we shall base on to calculate the mean. Next we need to get the cumulative frequency. Transfer the 4 here. We have a 4 plus 3, get a 7 plus 7, 14 here, plus a 4, we get 18 there. So now, having filled in all the columns of our table, we now go ahead to calculate the required parameters. So we start with the mean, x bar. This here is summation fx all over summation f, and summation fx 122.5 divided by summation f, which is 20. So when you compute this on our calculator, 6.125 is our mean. We need to calculate the mod is equal to L1 plus we have D1 over D1 plus D2 times the class width. Now, the model class is the class with the highest frequency. Our highest frequency here is 7. So, D1 is going to be 7 minus 3, which is giving us a 4. D2 will be 7 minus 4, which gives us a 3. So, D1 is 4, D2 is 3. Then L1, the lower class boundary, the model class, that is 5.95. Capital C, this is 0.5. So we substitute in, we shall have mod being equal to 5.95 plus, we have 4 divided by 4 plus 3 times 0.5. Here is 5.95 plus 4 times 0.5, we get 2 all over 7. So we need to press this on our calculator. 2 over 7 plus 5.95. we get this value here, which we need to round off to 2 decimal places. So this will be 0.29. So you're going to get 5.95 plus 0.29. Our answer is 6.24. We need to also get the median, which is our third parameter. Median is equal to L1 plus we have N over 2 plus cumulative frequency before over the frequency of the median class times the class width. Now, we need to first of all get the median position. It's going to be equal to N over 2 value. So N is the same as summation F, and summation F is equal to 20 according to our table here. So the median position is the 10th value. Is equal to 10th value. Now we go back to our table and the cumulative frequency column and find where the 10th value lies. So the 10th value is a value that belongs to that class, right? So basing on that, we can be able to tell that the lower class boundary of the median class is this here, frequency of the median class, that one, and the cumulative frequency before is 7. And we know the class size as 0.5. So we can now substitute in there to get the median. This is going to be equal to 5.95 plus N over 2 is 10 minus cumulative frequency before is 7 divided by frequency of the median class, which is 7 times 0.5. This is going to be 5.95 plus 10 minus 7, we get 3 times 0.5, this is 1.5 all over 7. So we're going to bring our calculator here and we compute for this. So first we have 1.5 divided by 7, we're getting 0.21 to 2 decimal places here, and this is 5.95. So when we add this here, so the median is 6.16, and that is our value to 2 decimal places. So my dear viewer, I would like to thank you so much for being part of my community. And at the end of this video, we are going to have one tryout question, and it is now. So my dear viewer, you can be able to pause this video to have the question written down. And if you are new here at EduMath, please consider subscribing and hitting that notification bell. For now, from us EduMath, we say thank you so much for being part of our community, and God bless you. See you in the next video.